So me and Steph are from Conductor. Today our talk's on how to build a fast data tooling strategy. Some intros first. So I'm James. I'm Director of Product at Conductor. I have a background in enterprise data management and more recently building products, data products, and building developer tooling products specifically as well.
And I'm Stéphane. I'm the CTO, co-founder of the company Conductor. And in short, Conductor, we are building a developer tooling for Apache Kafka, so if you are doing data streaming in your company. And we are also building some fancy Kafka proxy if you want to improve, to enhance your Kafka infrastructure. Okay?
So a bit of context for today's talk. Probably at some point you might have seen the data in motion journey or the maturity curve. Usually it's presented as this seamless growth curve with no hiccups along the way. But actually, in reality, it's not always that smooth. So we like to show the accidental shared service tooling late strategy curve. And this really happens due to the nature of which fast data matures in your organization. Usually you start off with a specific use case, a specific POC or a project. And essentially at this point, what you're trying to do is just prove out the value of fast data. You're trying to get something running in production, trying to prove out the value, and you're not really thinking ahead about any of the challenges that you might encounter along the way, how you're going to onboard lots of different domains in the future, lots of different projects, and how you're going to deal with a massive proliferation of microservices, streaming applications, and obviously data resources. So today's talk focuses on a fictional story of what happens along the way, and some of the methods, some of the strategies you can use to make sure you're thinking about this stuff up front, and you don't then have to reverse backwards later. The other thing that we're going to focus on today is, throughout the talk, we're going to talk about all of the different actors. So hopefully you all see yourself somewhere on this slide. Lots of different actors involved in the fast data tooling strategy, or the fast data ecosystem. All of them with different needs, all of them have different goals, and therefore they have a different stake in the data ecosystem. For example, software engineer, responsible for building applications, streaming applications. For a software engineer, really they need to be able to troubleshoot, they need to be able to monitor and alert on those streaming applications and ensure business continuity. You've got data engineers who are building data pipelines. They're responsible for validation, ensuring data quality, reliability, ensuring pipelines have minimal latency. On the other side of the spectrum, you might have an architect, completely different interest. They want to standardize everything, they want to introduce frameworks and ensure that there's business reliability. They have a focus on data security and data governance, unlike perhaps the software engineers who may have a small eye on that. So lots of different actors in the ecosystem, but as I said today, it's nearly 5 o'clock, people are tired. We're going to go on a journey with a fictional story of Kamaz, or Kamazon. They are a typical retail company for the sake of the deck today. So let's jump into Kamazon's story. Have you ever had an order substituted in your Sainsbury's grocery delivery? It's really annoying. It sucks. Just like Harold, our Kamaz customer, he's had a repeated situation where his order's been substituted for a different one, and he's not happy about it. So he's asking the question of Kamazon, why can you not keep track of your damn inventory? Very valid question from Harold to answer. He's unhappy, the customer experience is poor. And therefore, a use case was born for fast data. Essentially, we have this need inside the business for real-time stock availability. At this stage, we're talking about a single domain. We're talking about the supply chain domain, and their goal is to essentially get that real-time stock data into Kafka or similar technology. We're at the lower end of that maturity curve, so we're really talking about just two actors in the system at this stage. Software engineers who are going to do the development, and the architect might be there to say, okay, this is how you get the data out of that system or out of that stock inventory system. So very plainly, our architecture looks like this. We have some data in some Oracle data stores, and we have our stock integration app, which on some regular cadence is fetching data from those Oracle data stores and pushing that data into Kafka in the form of messages. So data's in the pipe, but it's not very useful yet. It's only useful if someone uses it. Therefore, we don't have our end-to-end use case yet. We want to achieve something like this, which you've probably seen on an e-commerce or a shopping store before. And essentially, we need the second domain to enter the ecosystem. This time, it's our shopping or our e-commerce team. And essentially, their goal is to consume that real-time data and then update the website. We're still talking maturity, early POC, just our software engineers and our architects involved. So our architecture now looks like this. We have some data being produced into Kafka, into our stocks topic, and now we have our shopping or e-commerce domain consuming that data and updating that information on the website. Sounds simple?
Looks good. Looks easy.
Not that simple. Once you actually get into production, as Morpheus very clearly put in the matrix, there is a difference between knowing the path and walking the path. And for these people that have never used fast data before, they're involved with a whole bunch of new streaming concepts and challenges. So these new streaming concepts start to impact the productivity of the software engineering teams. On the left side, we have a steep learning curve. So we've got a whole bunch of technical jargon that people are not familiar with, things like topics, partitions, offset, stream, schema registry. And at the same time, you have the technical implementation behind that. So you're dealing with the CLI, new APIs, and new metrics like consumer lag and things like that. Your software engineers need the ability to troubleshoot. So is their consumer app crash looping? Maybe they've had a report of a poor customer experience and they need to check, is the application lagging? They don't really have great visibility of it, which takes us on to that last point. How do they need to find a missing order? They need to be able to trace an order ID when it happens, and they just don't have that visibility today. Kamaz have a Black Friday deal and they have massive volume and everything breaks down and they start asking the question, you know, what's the throughput in this stream? How can we make sure we can plan and provision ahead for next time? Nonetheless, the real-time inventory project is a success, and our supply chain and our shopping domains are crowned internal champions. They are the first team internally to make use of first data. But what happens next? So the PM, guilty, I've been here before, has got a whole new experimentation roadmap. They're dreaming of different things they can start to do with this fast data, like 5 people are looking at this item now. Similar users also purchased this item, and your delivery is 3 stops away. Probably all familiar with this kind of thing from various applications, products, and services. So essentially, real-time use cases everywhere. And this time, the CEO of Amazon even has his own request. He thinks it would be great if our recommendations were based on the real-time weather.
This is a real story, by the way.
Okay, whatever. Random, but whatever. And he's going to push it through because he's the CEO. So now we have this new use case, but it's actually kind of interesting this time, and it's a little bit different because this involves 2 different types of data. We've got our geo data, and we've got user data that we need to marry up here. And this starts to involve a 3rd domain, our checkout domain. And the interesting thing here is they have a new challenge. Their new challenge is processing PII and sensitive data. So when we talked earlier about, did we think about this up front? In this case, the checkout team didn't. And the second piece is more on the data processing side. So they now need to join real-time data streams. So we're talking about new technologies. We have moved up the maturity curve. We are very much talking now about mission-critical, connected lines of business in our overall fast data ecosystem. And we have a bunch of new challenges to come with it. Our platform team and the SecOps team just joined the Kafka channel on Slack, and they're asking questions that nobody's asked before. There's a governance steward who starts to ask, who can access this data? Is it already being replicated anywhere, and are there downstream teams consuming this data when they shouldn't be? On the security side, you've got architects, chief security officers asking things like, is the data encrypted? Do we have a language agnostic encryption solution? And is it encrypted in transit at rest? Questions that you're going to ask at some point down the line. And it gets worse. So with all these new domains and all these new use cases, we start to involve the data engineering guys and the DevOps guys as well. So they're now part of this fast data ecosystem. They've joined the Slack channel Kafka. It's great because the mindset internally has shifted to real-time data. And they've shifted that one because they want to tackle the competition and they're going to be super competitive in the e-commerce industry. But you can see the knock-on effect of this. We have new domains, supply chain, shopping, checkout, data engineering. And what's great is it throws up a whole bunch of new data intersections, customer, geo, order, IoT. And that means more data processing. And now we're talking about technologies like Kafka Streams, Apache Flink, KSQLDB, Apache Spark. These are the mechanisms in which you're going to kind of join, enrich, aggregate all of these real-time data streams. And it also brings a whole bunch of new fast data concepts. Lag, stateful operations versus stateless operations, different windowing strategies, how to build, deploy, observe, maintain all of these different streaming applications. And it doesn't stop until finally we get to this. And this is the proliferation that we warned about. This is when you have many, many domains, you have many, many microservices, you have data stores, you have applications, and essentially you didn't plan for this.
So the question is how to not do the same thing as we saw. I'm pretty sure most of us here are living what James just described, all this organic, growth in a company where you grow and it's a mess at the end. We often make the bad decision to live with it and to try to fix things later, when actually the best solution, as we're going to see, is to be aware at the beginning of this journey and to fix things before. So we try to split, to find solutions that we saw in our customers, and to evaluate them on 3 dimensions: the cost, the velocity, and the organizational knowledge. For instance, if you look, consulting, learning and development, outsourcing, and tooling are the 4 big options if you want to have a strategy, a fast data strategy, or a Kafka strategy. Learning and development, it's what we live for, as developers, data engineers, and stuff. We are always learning. It's amazing. It's not that costly, but we are learning at a slow pace generally. But at the same time, we are building a very good organizational knowledge, meaning we are learning for ourselves, for the company, and so this knowledge is not lost. If we compare to consultants are amazing. They are costly at the beginning, but you can go very, very fast. In 2 weeks, generally 2 weeks, 1 month, you know where you are going thanks to consultants, because they saw a lot of things on the field, so they have the experience, and they just give you this experience against money. But when you do that, you do not build any knowledge internally. So all this knowledge gone, and it's for the consultants. So to be careful with that. Same thing more or less with outsourcing. We love to outsource, all companies out there are outsourcing your development stuff. It's good, but you are totally forgetting about the internal knowledge that you should keep internally. And the last one, the tooling. We are going to focus on that just after. The tooling from our perspective is generally as a low cost or free totally. You can get a good velocity because thanks to the tooling you get a very good visibility and a lot of cool options. So generally you can go way faster than if you don't have tooling. And the last thing is from an organizational knowledge perspective, it's often amazing because you can share with all the team, all the people in your organization how to use this tool, and the tool will help you, will guide you to understand the underlying tech, like Kafka, for instance. Tooling, we tried to analyze 4 big toolings that we saw on the market in our customers: dev tooling, CLI, bespoke tooling, so homemade tooling, and the GitOps approach. We are going to deep dive into each of them just after, but you can see that we assess them on 7 criteria: velocity, observability, security, governance, and so on. You see 2 big patterns. The dev tooling takes a big place in this thing. They are quite good. The GitOps approach is quite good as well, but introduce some maintenance. And the bespoke tooling introduces a lot of maintenance. We are going to deep dive. So CLI, we all love CLIs. I'm pretty sure most of us developers, we love CLIs. It's amazing to get started, but at scale, it does not work at all. I really hope that nobody is using the CLI to do production stuff. It's cool for a POC or to get started or to explore something ad hoc, but this is not a strategy. It comes bundled typically with the technologies like Kafka, but this is not something sustainable on the longer term. You cannot share with someone a CLI. You cannot put a lot of security on a CLI. It's just a random tool. So we are not going to talk too much about it. What is more interesting is the bespoke tooling. So bespoke tooling, all companies generally, when you have some technologies, you want to build your own stuff to answer to your own needs, basically your own requirements. On the left, you can see some existing, some companies working with us, and this is typically the tools that they build internally, but they do one requirement, but a company always try to spread their internal tooling to the whole company. But when you have hundreds of developers, they are going to ask for way more things over and over. And you are going to have to maintain this bespoke tooling. Your company, it's about retail, like Amazon, it's a company about retail. It's not a company about Kafka or some big data technologies. So you generally need to maintain them. Maintaining them is very heavy from a cost perspective. To maintain a software, you need developers. Developers, 100K, the full package in London. Sometimes you have a tool, it costs like 50K. Do you prefer to pay a tool 50K or to pay 2-3 developers 100Ks, on a year? This is something that often we are reluctant to buy a tool because it's very expensive, but actually you are going to pay people to do the same thing, and it's way more expensive. You have to maintain it. So maintaining it means like you are going to scale in multiple domains, like the Amazon thing. So people, departments, data engineers, ops, architect, they are going to want to use it because it's like your company tool, but they are going to need their own stuff. So you are going to build more and more stuff and to maintain it on the long run. And then you need a lot of integration. You need, as a company, you need security. You need governance on who can do what on your tool. Bespoke tooling, same thing. If you give a tool to your organization, you need a lot of rules to make sure that nobody is going to access the data that they are not supposed to read. You want to be sure that every action that your users, your developers, your data engineers are using, that you know what they did when. You want like auditability on all these kind of things. And so at the end, you start to build this bespoke tooling. It was a very good intention, amazing. It takes 1 week to develop a POC. But when you look on the mid-long term, it's going to take you one team of 3-5 people for years, and you are never going to be able to focus on something else. Your business is retail, your business is bank, your business is not actually some bespoke tooling that you are never going to be able to do everything that your company needs. Okay?
Is there a situation when it makes sense at all?
So it makes sense when your company has very specifics internally, like you have your own other softwares, you have old integration, with legacy systems, you have old stuff, and only your company is aware of this kind of systems, and it's not something on the market that is going to be fully integrated with your own, internal ecosystem. And this is where actually the bespoke tooling is amazing, but the bespoke tooling should be about your company, your organization knowledge, not about the technology itself. It's technology like Kafka, like BigQuery, like all the things that we all know. It's not specific to your company. So why are you trying to build basically a bespoke tooling on something which is actually a common knowledge, out there? And this is often what we see, the big mistake. And people come to us because we are a developer tooling, saying, all our developers, they want more and more things. Oh, they want consumer groups, super alerting. They want some encryption. And our bespoke tooling is not answering, and we don't have the people actually with the knowledge to do that. And so they are locked in, we have this bespoke tooling, and we don't want to invest too much. And some companies keep investing, and it's so crazy. Sometimes there are like 20 people on developer tooling, platform engineering. Sometimes they take care of that. I don't know if some of you are platform engineers here, but you are asked to build internal tooling more and more on the technology itself. Is it really what you want to do? Is it where your strength is? And often the answer is just no.
So one of the other things we alluded to on the tooling graph was GitOps. So GitOps less as a strategy, more of as a framework, let's say. It can really help alleviate scaling issues. Really great for infrastructure management, application deployment. If you're not familiar with GitOps, like the too long don't read version is we essentially have a desired state in some external source of truth, usually GitHub repository. And then we use automation in the form of a reconciler to essentially ensure we achieve that desired state in a runtime environment. That runtime environment could be your cloud provider. It could be your managed Kafka provider. To give you a real tangible example, you might store an infra as code representation of all of the resources desired to run your streaming platform. And then your reconciler might use APIs to essentially make changes when a pull request is raised to change that state to make sure that those physical resources are actually created in the runtime environment. GitOps is great for governance. We alluded to that as one of the key dimensions on the radar graph. So really when we're talking about GitOps, we're talking about raising pull requests. If you imagine, if we think back to the journey and the proliferation of microservices and streaming apps, ultimately what that's going to end up being is a burden on some central platform team whereby you're getting requests through Slack, at the coffee machine, via email, to basically have new infrastructure and new resources deployed. Instead, with GitOps, that request is coming through the form of a pull request in GitHub, and that gives you the advantage of a programmatic request that is structured, that is testable, auditable, and it gives you the chance to say, actually, as part of the deploy pipeline or the approval rejection process, I'm going to validate it against a bunch of policies or business rules that I've implemented. CONDUKTOR actually have a Kafka proxy where you can inject these business rules inside Kafka and essentially basically check that topics are being requested with a certain number of partitions and reject them in the case. If you want to know more about that, obviously come and speak to us at the booth. We're not going to focus on it too much today. So when does it make sense to use GitOps? Typically when your engineers outweigh your ops guys. It's not uncommon in a large enterprise to have literally 3 DevOps guys for like hundreds of developers. And the actual process of making them use GitOps means as a requester for infrastructure or resources, it's pushing that ownership on them to say, here's what I want, and then that central person or that person behind the PR to say yes or no. But it won't solve everything. So imagine requests are coming through in the form of PRs, and there's someone sitting behind a computer somewhere that's basically saying, okay, should I approve this or not? And who is that guy approving the PRs? Why do you need so many partitions, dude? Does he really have the business context behind each request? Maybe when you get started and the scope is small, they do. But at some point they become a bottleneck because they start chasing that person going, who are you? What team are you from? Should you really be requesting this infrastructure? So it won't solve everything. On to third-party developer tooling. If you've never seen any of those logos before, you're at the wrong conference. But ultimately here, the path is often already paved. If we think about Morpheus earlier and what he said, be it Docker for containerization, be it Jenkins for CI/CD, Airflow for orchestration, GitLab for CI/CD, Lens for Kubernetes. If you're not using it, it's great. And so essentially, there's nothing wrong with using curl, right? But if you're going to do some proper REST API testing, use Postman because it's much better. So what we're saying here with third-party developer tooling, and you can see by the radar graph, is essentially it's probably the best spread in terms of minimal cost, minimal maintenance, and very good, usually on things like security, governance, helping you go fast, and fostering organizational knowledge. Observability is a tricky dimension. Obviously, if you're buying Datadog, it probably scores a 10. But often, the core piece of developer tooling isn't observability tooling, so it may have something in there, but may not have a lot. So essentially, we're saying that third-party dev tools are like the best in class for supporting all of those different actors that we've kind of traversed through the story today. It allows you to focus on your core domain. It does help foster knowledge because of visual learning, seeing things, and often these tools have collaboration baked in as well. You won't waste your time building third-party integrations for LDAP, OIDC, different SSO mechanisms, RBAC, permissions, because chances are they're already baked in. Support. You're not just buying a tool, but you're also buying, an expert form of people in the form of, webinars, knowledge-based documentations, and other educational resources. Coming back to the use case point earlier, if you're building bespoke tooling, and I've been on teams doing it before, typically you're looking to solve a specific problem that team you're in has today. The problem with that is once it starts to scale, that tooling doesn't scale for all of the different people. Whereas with third-party tooling, usually we're looking at supporting more than one actor. We're not just looking to support the software engineer. We're looking to support the DevOps lead as well. And lastly, documentation. No one likes writing it. It's probably already done for you.
So what we saw here is you saw the original use case, Kamas, like we all start like this organically, becoming a mess. You saw all the solution there. We truly believe that when you grow, you are going to need this governance and security thing. It's like, yes, you are an organization. You are not just a freestyle developer doing one thing on their side. All these kind of things are organizational based. An organization is not playing with data. Data has a real value, and data scale in the whole company and outside actually. So you won't escape this kind of concern. So if no matter what you do, bespoke tooling, consulting, homemade, whatever you want, you will need to take care of that. And our message from a strategic perspective is, do not try to underestimate the tooling. Do not try to say, yeah, it's expensive, I don't care, because you are going to pay way more at the end. So it's better to invest 50K initially than investing 500K in a year of people, which is way more indirect, but you are still going to pay them from an organizational perspective. And so now the success path that the big answer of this talk actually is what we saw, what is truly the solution that is the best for us and the one that we recommend is to not start with tooling at all. Start by talking with experts, with consultancy services. Really, we are not even a consulting services. We don't care. Check a lot of people here. They are, and they are very good at telling you what is your use case, what are you trying to achieve. Okay, you should do that. Tooling won't help you. Tooling is here when you already have something in place where you know where you are going. Consulting services, top notch. Go with them. And then when you are in production, only then you go to the DevOps thing, to the dev tooling stuff. You need to equip your data engineers, your software engineers, maybe your architect according to the tooling. And GitOps. GitOps is something that we saw half of the companies working with us have a GitOps approach, because this is a single source of truth, Git. They have auditability, they have all the good things, but you need a dev tooling combined with a GitOps approach. This way you are reconciliating the best world, your GitOps for your organization and a dev tooling for your people working with your technology. And then, as we said, you won't escape the security. Security, encryption, data masking, who has access to what, auditability, airbag, roles, custom things. You are going to need it. And generally, the dev tooling answers this, and you will need it as a company. This is for sure. So the best is to start upfront with security. Often we saw companies coming with us, hey, we have an open bar Kafka, we have an open bar where everyone has access to everything. And they say, yeah, but no, we want to secure things. And so it takes way more effort to secure things when it was already open than to secure it upfront. And the last one is when your CFO is going to come to you because you have good success, you have data streaming everywhere. About cost. Streaming comes generally with a big cost. You don't see it, it just accumulates, every month streaming accumulates until you have very big invoices. And so you need a strategy to actually reduce it. This is something that you should really have some cap, because 5K, 10K, 20K, 100K, it's very, very easy when you do streaming. And the worst part is you cannot stop. When you have 100K, you cannot stop something. It's streaming, so it's running in real time. Your data strategy is not going to stop like this, so you cannot escape the cost. So you have to think a bit ahead of time, like, okay, where are we going with this thing? Are we going to pay millions per year on this thing? Can we do it? this is typically exactly the curve that we are seeing. So be aware when you build your data strategy.
And we've not focused that much on the latter half today, but if you are interested in it, then our colleague is doing a talk tomorrow, I think around 2 o'clock in the same theatre, which is going to focus very much on the top part of that curve rather than the earlier half.
Yeah.
So
thank you very much.
That's it. Yeah, thank you very much. Yeah, cheers.